So we were discussing the organic chemistry, introduction to organic chemistry, how we define the term isomers, and there are different types of isomers. First, the structural isomers. Structural isomers means they have the same molecular formula but different structure. We call that as structural isomers. So, and these structural isomers are actually divided into chain isomerism, position isomerism, and functional group isomerism. So what is a chain isomerism? Compound with the same molecular formula but different skeletal formula, they are referred to chain isomers. Like example, 5 carbon atoms are there joined together having 2 ends only. Here 4 carbon atoms in the skeleton and 1 is a branch, and here 3 carbon atoms in the skeleton and 2 are the branches. So whenever branches are there, the structure, the skeleton of the carbon is different. We call that as chain isomerism. What is the meaning of position isomerism? Position isomerism means when the position of the functional group is different. Like this is our first carbon, second and third. So bromine is attached with the first carbon. So it is 1 bromopropane. And here bromine is attached with the second carbon. So it is 2 bromopropane. And what is functional group isomerism? The compounds, they have the same molecular formula but different functional group. As you can see, OH is there, alcohol, and this O is there. It means ether as a functional group. So they have different functional groups, but the molecular formula is same. This contains 2 carbon atoms, 1, 2, 3, 4, 5, 6 hydrogen, and 1 oxygen. This also contains 2 carbon atoms, 6 hydrogen, and 1 oxygen. So when compounds have same molecular formula but different functional group is attached, we call that as functional group isomerism. Position isomerism means same carbon skeleton but different position of the functional group. We call that as position isomerism. And chain isomerism, in which the skeleton of the carbon structure is different. Is it clear, the 3 type of isomerism? So basically, when we say isomerism or isomers, isomerism is actually divided into 2 main categories. One is called structural, and another one is known as stereo. And the structural isomerism is having 3 divisions. One is known as chain isomerism, position isomerism, and functional group isomerism. Chain isomerism means the carbon skeleton is different. Position isomerism means the position of the functional group is different. And functional group isomerism means the functional group is totally different. Stereoisomerism is divided into 2 classes. One is known as geometrical, another one is known as optical. Optical we'll discuss in A2, so you don't have to study, but geometrical you will study in AF. And even this geometrical is further divided into 2 categories. One is known as cis or Z, another one is known as trans or E. That we'll discuss in alkene topic. So the main definition of isomer, same molecular formula but different structure. That's called structural isomerism. And stereoisomerism, the geometrical one, we'll discuss in alkene topic. So after the introduction of organic chemistry, the topic alkanes, we already discussed that this part, that alkanes, they have the general formula CnH2n plus 2, and these are saturated hydrocarbons, and most of them are used as a fuel, which are extracted from the crude oil. The fraction distillation of the crude oil we already discussed. Then the fraction which we obtain, the heavy fractions which are having more carbon, we crack them because smaller or lighter fractions are more useful as they have many use as compared to the larger fractions. Reforming means when we convert the straight chain into branch or cyclic, we call that as reforming. And alkanes can be used as a fuel. How we use them as a fuel? By burning. The complete combustion result in a formation of carbon dioxide and water, whereas incomplete combustion leads to carbon monoxide or unburned carbon, which is also known as the black soot. Then the pollution from the combustion, because the fossil fuel contain trace of sulfur, so when we burn it release sulfur dioxide, which can leads to acid rain, and oxides of nitrogen in the car engine. The electrical spark cause a reaction between the nitrogen and oxygen, which leads to formation of oxides of nitrogen, result in photochemical smog as well as acid rain because it is acidic oxide. The global warming, what happened? The average temperature of the earth is rising due to certain gases which have the greater tendency to absorb infrared radiation into the atmosphere, such as carbon dioxide, methane, and water vapors. These all are greenhouse. And what is the characteristic? Why they have tendency to absorb the infrared radiation? When the bonds are polar, so when we have polar covalent bonds, they have a tendency to absorb the infrared radiation. So as they have tendency to absorb infrared radiation, the bond in carbon dioxide bonds are polar. Why? Because it is formed between the two different atoms which are having difference in the electronegativity. Same thing, methane, carbon and hydrogen, difference in the electronegativity leads to absorption. Water, H2O, a bench structure but difference in the electronegativity of oxygen and hydrogen leads to absorption of these infrared radiation. So water is the main greenhouse, but it is natural, followed by the carbon dioxide and methane. And the carbon dioxide level has risen significantly. Why? Because of human activities, as we are using the fossil fuel, burning the fossil fuel, so we are increasing the amount of carbon dioxide. Then the bond breaking, whenever a bond break in the substance, the bond breaking can be a homolytic fission or heterolytic. What is the meaning of homolytic bond breaking? When a radicals are formed, the term radical means they are very reactive and they have unpaired electron. We call them as radical. So example, hydrogen bonded with another hydrogen. So due to any external factor, the bond break. So when the bond break, because both have the same tendency to attract the electron, so both of the hydrogen atoms take their electron back. So how we represent? We represent by a half arrow. So as they both of them take their electron back, the bond will break, and this leads in a production of hydrogen radical, and radical are reactive species which have unpaired electron. Same way, like if we have chlorine belongs to group 7, so it share one electron with another chlorine atom. So due to external factor, the bond will break and both chlorine atoms will take their electron back. This result in a formation of chlorine radical. So this is called homolytic bond breaking. So homolytic bond breaking, it produces free radical. There is also heterolytic bond breaking or heterolytic fission. What does it mean? It means it results in a formation of cation and anions. So the one which is more electronegative, like example, hydrogen bonded with chlorine. So chlorine is more electronegative, partial negative on chlorine and partial positive on hydrogen. So due to the external factor, if this bond will break, because chlorine is more electronegative, so it has a greater tendency to attract the shared pair. So when the bond break, chlorine take both of the electron, and how we represent that it is taking both of the electron is by a complete arrow. So this result in a formation of hydrogen plus and chloride minus ion. And this type of a bond breaking, which result in a formation of ions, positive and negative ions, we call that as heterolytic fission or heterolytic bond breaking. Is it clear, the concept of homolytic and heterolytic? So arrow is important. If it's a homolytic bond breaking, you represent by half arrows. If it's a heterolytic bond breaking, you will represent by the complete arrow. Then the mechanism, the term mechanism means how the reaction proceed. In AS, the mechanism which you have to learn free radical substitution. You have to learn nucleophilic substitution and elimination reaction. These are the mechanism which you have to learn in this AS. So the first one, in whenever alkanes are there reacting with halogen, in the presence of ultraviolet light UV, this reaction is known as free radical substitution reaction. What happened in this free radical substitution reaction? If I write the overall equation, the overall equation, like we have methane. So methane is CH4. It reacted with chlorine, which is Cl2. In the presence of UV, ultraviolet light, so chlorine will take position of hydrogen and hydrogen will go out. That's a substitution reaction. So this result in a formation of CH3 Cl plus HCl. So CH3Cl plus HCl is a result of alkane plus halogen in the presence of ultraviolet light or UV. This is overall reaction, but in exam they normally don't ask for overall, they ask for mechanism. Mechanism means how this reaction proceed, like what are the steps occur during this reaction. So what are the steps occur during this reaction? You have to learn this. The first step is called initiation or startup reaction. So what happened in initiation reaction? We have a chlorine molecule. A chlorine molecule is there which turn into chlorine free radical due to the ultraviolet light. So when radical is there, how we represent a radical? We put a dot at the top of the element. So chlorine, and how we represent homolytic bond breaking? Each chlorine will take their electron back, and this result in a formation of chlorine free radical. This we call initiation or startup. Then the second is propagation. What happened in propagation? So if we have methane, which is CH4, reacted with the chlorine radical, so this result in a formation of methyl radical, like one of the hydrogen is removed, homolytic bond breaking, methyl radical, and it forms HCl. And this methyl radical, which is produced, react with another chlorine molecule. So when it react with another chlorine molecule, what it result? It result in a formation of methyl chloride CH3Cl plus chlorine radical. So why we call this as a propagation reaction? Because chlorine was there in the beginning, the first step of propagation, the chlorine was the reactant, and it is also produced in the last step. So, and that chlorine can again react with another methane molecule. So that's why this reaction is called a cycle reaction or a propagation reaction. So propagation step involved two: methane reacted with chlorine, give methyl radical plus HCl, and then methyl radical react with another chlorine molecule to form methyl chloride and chlorine radical. So this is what happened. Now the last stage is called a termination. Termination means how the reaction stop. So what happened in termination? Termination means how the reaction stop. So in termination, all the radicals convert into molecule. Like if chlorine radical react with another chlorine radical, it will form chlorine molecule. If methyl radical react with chlorine radical, it will form methyl chloride. And if methyl radical react with another methyl radical, it will form C2H6. So the last stage is called termination. Termination means how the reaction stop. So reaction is, as you can see, all this, the reaction was proceeding because of the free radical. So if the free radicals are stopped, then the reaction will also stop. Is it clear? This mechanism of free radical substitution reaction for alkanes. I'll give another example. Any doubt or question till this point? So in exam they can give you any halogen as well as they can give you any alkane, but the reaction goes in the same way. Example, if I say we have C4H8, H10, sorry, butane, and we want to show substitution of in butane, so C4H10 reacting with chlorine molecule. So chlorine will take position of hydrogen. So it will be C4H9Cl plus HCl. That is overall. But we have to write the mechanism. So what happened in initiation? Initiation is the production of the free radical. So how free radical is produced? Molecule of chlorine is there. Instead of showing in this manner, I can write as Cl2. So there's Cl2. It will form 2 chlorine radical. Or if you want to show a chlorine molecule, you can represent in this manner. It forms 2 chloride free radical. Then propagation. So it's a general way. When methane was there, methane plus chlorine radical. But now we don't have methane, we have butane. So what will be the steps? It will be butane, which is C4H10 plus chlorine radical. And what it result there, when methane was there, it was methyl radical. If butane is there, it will be butyl radical. So C4H9, one of the hydrogen will be removed by homolytic bond breaking, and that will combine with chlorine to form HCl. So it's the same thing. One of the hydrogen removed from alkane and result in a formation of a radical. And this C4H9 radical react with another chlorine molecule. So here CH3 radical react with a chlorine molecule. What it result? It result in a formation of C4H9Cl plus chlorine radical. So chlorine radical is produced again. And the last one is termination. How the reaction stops, how the reaction terminate. So when chlorine radical join with a chlorine radical, it will form chlorine molecule. When butyl radical react with chloride radical, it will form C4H9Cl. And when C4H9 radical react with C4H9 radical, it result in a formation of C8H18. Is it clear how to complete a free radical substitution reaction, or how to write a mechanism for free radical substitution reaction between alkanes and halogen? Any doubt in this part? So initiation is there, propagation is there, and termination, the 3 steps. The first step, it result in a formation of a free radical. Second step, the chlorine free radical react with, like example, methane, form methyl radical, which react with a chlorine molecule to form methyl chloride and free radical of chlorine. And then termination means when the molecules are formed by the free combination of the free radical, we call termination. So this is valid free radical substitution reaction, same way it occurs for other substances. So this was topic alkanes. Now we'll do some questions related to the topic.